Okay folks, let's go ahead and record a quick video on how to do test 2. First problem, a math problem. Bumblebees cannot see the color red, but they can perceive near UV light at 300 nanometers. So how much energy? So we're turning a wavelength of 300 nanometers into energy. So we have to go wavelength to frequency to energy first. So step 1 is to turn nanometers into meters. And we have in 1 nanometer, well, we have 10 to the 9th nanometers in 1 meter. So that means there's 3.0 times 0 times 10 to the negative 7th meters. Next step is C equals lambda nu, or lambda v. And so we're finding the frequency. So C is the speed of light, 3 times 10 to the 8th meters per second. And I'm going to divide that by my 3.0 times 10 to the negative 7th meters. So real quick, that's going to give me 1 times 10 to the 15th inverse seconds as my speed. Finally, E equals h nu, or hv. So we're going to have 6.6 times 10 to the negative 34th times 1 times 10 to the 15th. And if you do that math, you should get 6.62 times 10 to the negative 19th. I rounded vigorously for that one, but 6.6 times 10 to the 19th. Now, which is the p orbital? Well, s orbital has 1 lobe, p orbital has 2 lobes, d orbital has 4 lobes, and f orbital has 2, 3, 4, 5, 6, 7, 8 lobes. Now, what is the full electron configuration of calcium? You can use the periodic table to figure this out. Calcium is right here. So if there's rho 1, here's our S, 2, 3, 4. Here's our D, there's our P. So we'll do 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. The next question is a trick question. Which element would have the higher electron affinity? Well, we said in class the electron affinity increases moving left to right, top to bottom, or bottom to top. However, it stops here. These guys have 0 electron affinity. They do not want electrons. So even though argon is further to the right than chlorine, the answer is chlorine because argon has a full octet of electrons. Last problem on the first page. Which trend decreases moving left to right? Left to right. EA goes up. Ionization energy goes up. Z effective goes up. The only thing that goes down is size goes down. as we go from left to right. The other math problem, average ham radio frequency, runs 5405 kilohertz. What would the length of this radio wave? So we have a frequency 5405 kHz, and I need to turn this frequency into wavelength in meters. So the first step is to turn our kilohertz into hertz. So in 1 kilohertz there is 1,000 hertz. So my frequency is 5.405 times 10 to the 6th hertz. Then C equals lambda nu. So we have to solve for our C. We have to solve for our lambda. C times 10 to the 8th meters per second. We're going to divide that by 5.405 times 10 to the 6th inverse seconds. And so if you do that math, you're going to get 55.5. Now, what is the condensed electron configuration of technetium? So right here. So to start off, for condensed, I need the noble gas that comes right before it, krypton, and then I'm going to work my way across. So krypton, then 5s2. Here's the only really tricky part. Technetium 1, 2, 3, 4, 5, but it may be on row 5, but it's 4d5 because the D trails by 1. Now place these isoelectronic series in order of increasing size. Well, if isoelectronic means same number of electrons, then it's all about the nuclear charge. So nuclear charge, positive is smaller, negative is bigger. So the more negative, the bigger it is. So 2 minus and 2 plus, we want the ones where the largest positive is first and the largest negative is last. Now, following condensed electron configuration describes what element? So neon right here, 3s2, 3p2. 3p2, that's silicon. I'm just asking you to work backwards. Now this one was a tricky one. Which statement about ionization energy trend is true? Whenever the number of protons increases, the ionization increases. Say, wrong, because as we move left to right, that's true, but as we move down, the number of protons increases, but the ionization energy decreases. Ionization energy decreases whenever electron affinity increases. That is exactly opposite. They both go up, because one looks at a positive number, one looks at a negative number. They both go up in the same direction. Ionization energy depends on Z effective and atomic size. That's just absolutely true. And halogens cannot be ionized to cations. That's patently false. Everything is possible. It's whether it is practical or easy. Now, this one was another tricky one. Lead 2+. Condensed electron configuration of lead 2+. So lead is right here. So xenon is my starting point. Xenon is my starting point. working my way across, 6s2, 4f14, 5d10, 6p2. So this guy right here is actually lead 0. And the rule is, as we lose electrons first from the P, then from the S, and then from the D. So to be 2+, we have to lose these 2 p electrons. So the guy that properly represents that is D. C is close. C would be Pb 4+, because it lost the 6s as well. But we want to lose only those 2p electrons. Last page now. Which of the following elements would likely to have the following successive ionization energies? So 787, 1500 is about doubled. 3200 about doubled. It increased by a factor of about 1,000. And then 1400, it increased by a factor of about 4 times. The big jump is right here. The big jump is right here. When it goes from 4,000 to 16,000. So it means it can lose 1 electron, 2 electrons, 3 electrons, 4 electrons easily. So 4 electrons means it would have to be in IVA, number 4, column 4. So carbon, silicon, germanium, tin. The only thing possible would be silicon. This one is also another challenging one. What element would be described by the following electron configuration when it has a charge of 2+? Notice it's argon 3d3. There is something key missing. When we add 2 electrons back, we would actually, should read argon 4s2 3d3. 4s2 3d3. So no matter what, the 3d3 does not change. So 4s2 3d3, that is vanadium. So that one was a little tricky, but still a lot of people managed to get that one. This one was a hard one. Very few people got that one right. It's right that this one requires on charge and size, but for the most part, charge. So beryllium is 2+, oxygen is 2-, sodium is 1+, fluorine is 1-, sodium is 1+, oxygen is 2-, magnesium is 2+, oxygen is 2-. The bigger the charges, the greater the lattice energy. So with 1 and 1, sodium fluoride should have been the smallest value, followed by sodium oxide. The next values look at the size because they're both 2 and 2. So beryllium and magnesium, how do they compare? Beryllium is here, magnesium is here. They both have oxygen, so that doesn't change. So beryllium is smaller. That's smaller. And magnesium is bigger. The bigger has the lower lattice energy. So we'd put MgO there, followed by BeO there. So that was the correct order of things. Now, how many unpaired electrons would be in sulfur? Well, if I fill my electrons, 1, 2, 3, 4, 5, 6, 7. Keep filling this in. You have 3s2. It's under oxygen. How many unpaired electrons do we have? 2 unpaired electrons. And this one, Z effective, increases going across the table. Across the table. Why? I had so many people answer things putting effect before cause. What you wanted to do is to talk about how, as going across the table, the number of protons increases linearly, while the shielding from valence electrons does not. So the idea is that the valence electrons do a poor job of shielding. Even though we're adding 1 electron for every 1 proton, we are not having a one-to-one relationship of Z effective to shielding. So you should have, essentially, we're empirically discussing this formula. Z, which is our nuclear charge, minus S, our shielding factor. The core electrons shield well, while the valence electrons shield poorly. And that is why the Z effective increases. Now, this increase in Z effective is also why we have the size decreasing. So the size does not predict the Z effective predicts the size. So that's why that's not right. The same thing with ionization energy, electron affinity. Z effective predicts those guys, not the other way around. And the last thing, the bonus question. Basically, I gave you points no matter what, but logically, if you had thought about it and thought about this, this may not hurt the company at all, but it will probably hurt the server in one way or another had they not gotten the correct change, because at the end of the night their drawer comes up short and they will be out of luck. So there may have been some more bonus had you recognized the fact who your actions might actually affect. But either way, that was the test. Well, have a good day.